Systems of equations, but this time they're the flavor of conics. We still have substitution, we still have elimination, but everything you know about systems is going to change. Not only do you have to be good at systems, you also need to be good at factoring to be able to handle one of these guys. So these notes have 4 examples. I'm going to do 1 substitution, 1 elimination, and we're going to save the other 2 for class. So you can try them on your own if you would like, of course. So how are we going to use substitution? The only time that you can use substitution is when you have a variable that is not squared that you can get all by himself. And when I mean all by himself is if you rearrange this, so this would change to x is equal to 2y squared minus 2 after you bring everything else to the right side. Notice how you don't have an x squared over here. If you had to rearrange this and you had an x squared on the right as well, you can't do this problem using substitution. So this is just really nice and simple. So x is 2y squared minus 2. So this is what we're going to do here. We are going to substitute that into this x. So we have, might as well start our parentheses now, 2y squared minus 2 squared plus 4y squared minus 4 equals 0. So from here, we need to square. So this is like saying 2y squared minus 2 times 2y squared minus 2. Remember, you don't distribute a squared into a binomial. So once we FOIL that, that's going to give us 4y squared minus, 4y to the 4th minus 8y squared plus 4. And then we have our plus 4y squared minus 4 equals 0. So now we're going to combine a little bit of like terms. So we're going to have those 4's disappear. We have a negative 8y squared and a positive 4y squared. So when we combine these like terms, that's going to give us 4y to the 4th minus 4y squared equals 0. But now you can see that we are down to just y variables, and we can factor out a GCF of 4y squared. And that's going to leave us with a y squared minus 1 inside. And this is why I said you need to be really good at factoring, because y squared minus 1 is the difference of 2 squares. So this is going to factor to 4y squared times y plus 1 times y minus 1. And all of those are equal to 0. So that's going to tell you that y is equal to 0, a negative 1, and a positive 1. So that means you have 3 different values of y that need to be substituted all the way back in to this equation to solve for x. All 3 of them. So that means we're going to have x is equal to 2 times, let's use 0 first, squared minus 2. So 0 squared is 0 times 2 is still 0 minus 2. So x is equal to a negative 2. Always write these as coordinates. So one of your solutions is negative 2, 0. We have to do it again. So this time we're going to substitute in the negative 1. So we have x is equal to 2 times a negative 1 squared minus 2. Negative 1 squared is a positive 1. Positive 1 times 2 is 2. Minus 2 is 0. So x is equal to 0. That means this is 0, negative 1. And we have one more to do. Now you have to substitute in a positive 1. So x is equal to 2 times a positive 1 squared minus 2. 1 squared is 1 times 2 is 2 minus 2 is 0. So x equals 0. but our coordinate is 0, comma, positive 1. So the solution to this system, all that work, is going to be -2, 0, 0, -1, and 0, 1. You must have all solutions. Okay? So again, not only do you have to be good at substitution, but you also need to be good at factoring to be able to handle these. Okay? So again, you can only use substitution if you can get one variable all by himself and he's not squared. So now we're going to go do elimination. Elimination is the same as it was before, but you must pick one and only one variable to eliminate, and it has to be a variable you can completely eliminate. So if you look at this, right off the bat, you're thinking, oh, I'll just get rid of my x squared. But that will still leave you with a y squared and an x. The variable by itself and squared must totally disappear. So for this, you're going to need to get rid of the y squared. So we can multiply this bottom one by a -1, and that'll change this to a positive x squared, negative y squared, and a -9. But that's going to mean our y squares will cancel. So x squared plus x squared is 2x squared. Y's went bye-bye. -16x. And then we have our -9 is equal to our -39. Now, of course, whenever you do these, they're supposed to be equal to 0. So we're going to add that 39 back over to the left. So we have 2x squared minus 16x plus 30 is equal to 0. So from here, you're thinking Batman, but I'm going to tell you no, you factor out your GCF of 2 first. And that's x squared minus 8x plus 15 is equal to 0. So 2 times, this is going to give you an x minus 5 and an x minus 3. Because a -5 and a -3 will add to a -8, but they multiply to a positive 15, and these are equal to 0. Remember, you cannot set 2 equal to 0. Only things with an x get set equal to 0. So x is equal to 5 and 3. So we have 2 values of x that need to be substituted back into one of these equations. Which one? Pick the shorter one. Pick the easier one to work with. So we're going to write it. So we're going to have our -x squared, I like using the originals, plus y squared plus 9 equals 0. Okay, that's our original equation. So we need to substitute 5 and 3 into x. So let's start with, I'll start with the 5. So we have a -5 squared plus y squared plus 9 equals 0. 5 squared is 25, but the negative is out front, so we have a -25 plus y squared plus 9 equals 0. So that's a y squared minus 16 equals 0. So y squared is equal to 16. So y is equal to, careful now, plus or minus 4. So 5 gave us 4, and 5 gave us -4. And that's just by substituting in the 5. Now we've got to go substitute in the 3. So that's going to give us a -3 squared plus y squared plus 9 equals 0. This is a -9 plus y squared plus 9 equals 0. Those are going to cancel. So y squared equals 0, so y is equal to 0. So the answer to this is 3, 0. So your final answer for this is we have 3, 0, we have 5, 4, and we have 5, -4. Now they don't always have 3 solutions. They can have 1 solution, they can have 2, they can have 4. I mean, think about it. This is a system of conics, which means if you were graphing, say, an ellipse and a circle, who's to say that it doesn't look like a circle and then you have an ellipse that goes like that? It intersects that 4 times. So you can have 4 different solutions. You might have a parabola that hits a circle once. So it can still have one solution. It could be a parabola that hits a circle twice. So you can have 2 solutions. It could be a hyperbola and a circle that intersect 4 times. So you must be careful and make sure that you're thinking that it's going to have 1, 2, 3, 4, maybe even no solutions. So you've just got to be really good with your algebra here. So again, you have to be good at systems and factoring to be able to do these. All right, this is your last video for this chapter. Actually, it's the last video for the semester. Woohoo! So have a good one. This is Longo, and I am out. See you bye. Go watch it again if you had a little bit of trouble.